Welcome to another deep dive. Today we're going deep into the world of garbage collection in .NET and how understanding this kind of behind-the-scenes process can help you write really efficient code.
It really can.
When you need to.
Yeah, for a lot of developers,
Yeah.
garbage collection is this mysterious thing that just kind of happens.
Yeah.
But even a basic understanding can be a huge help, especially when you're working on something that really needs to be performant.
Right, it's like having a secret weapon.
Exactly.
But before we get into the advanced stuff,
Yeah.
let's kind of break down this whole concept of garbage collection.
Yeah.
You know, I think a lot of developers, they hear that and they kind of nod along like, yeah. I know what that is, but like what is actually going on?
Yeah, so think of it this way.
Okay.
Like, you've just had a massive coding party, you know?
Okay.
Pizza boxes everywhere, empty energy drink cans,
Yeah.
all that stuff.
Yeah.
In the world of your application, that's data taking up memory. The garbage collector is like the cleaning crew
Right.
that swoops in and cleans up all those objects that are no longer in use.
Oh, so instead of us having to manually clean up each pizza box, the garbage collector just like
Exactly.
takes care of it for you.
Exactly. It does it for you.
Yeah.
And in managed languages like C# or .NET, it's not just about convenience.
Right.
It's about preventing these like really bad errors that can really mess things up.
Like what kind of errors are we talking about?
Like use after free and memory leaks.
Oh, God, those sounds.
Yeah.
They're a nightmare.
A nightmare to debug.
Yeah.
So how does this cleaning crew work? I mean, do they just kind of go on a rampage and start deleting things?
No, it's actually a very systematic two-phase process.
Okay.
Marking and sweeping.
Okay.
And let's start with the marking phase.
Okay.
Imagine a detective tracing connections.
Yeah.
You know? But instead of footprints, it's references in memory.
Okay.
It all starts with root objects.
Okay.
Like your active variables or static fields. Anything the application is currently using.
The garbage collector follows these references from the roots, marking every object that it can reach.
So it's like a treasure hunt, but instead of gold, we're finding the valuable objects.
Yeah. You got it. Anything left unmarked is considered garbage, and it's marked for deletion.
Okay.
Then comes the sweeping phase.
Okay.
The cleanup crew comes in and reclaims the memory from those marked objects, making it available for new objects.
So it's not randomly deleting. It's actually being pretty smart about it.
Yeah.
Okay.
Yeah.
So does it treat all objects the same way?
That's a good question.
Yeah.
It doesn't. And this is where generations come into play.
Generations.
Yeah, think about it. Like, sorting your laundry, you wouldn't throw your delicates in with your dirty work clothes.
Oh, no. I'd be worried about what would happen to them.
Exactly.
Yeah.
So the garbage collector has these different generations based on how long the objects have been around. You've got Generation 0, the fast fashion pile.
Okay.
These are brand new objects with short lifespans, you know, like temporary variables. The garbage collector focuses on this generation first because it's easy to clean up.
Right. Low-hanging fruit.
Exactly.
No.
So what about the objects that survive that first round?
Yeah. What about those?
They move up to Generation 1,
Okay.
objects that have been around a bit longer.
Okay.
And finally, we have Generation 2, the heirlooms,
Okay.
long-lived objects, including things like static data.
Interesting.
And there's also this special VIP section within Generation 2 called the Large Object Heap, the LOH.
Oh.
This is for those really massive objects that need special care.
Okay. So it's like a tiered system for memory management.
You got it.
So the garbage collector focuses on Generation 0 first,
Right.
then Generation 1,
Yeah.
and then finally gets around to Generation 2.
Exactly. It's all about efficiency.
Yeah.
Short-lived objects are more numerous, so cleaning them frequently keeps things running smoothly.
Okay.
But this generational approach also plays a key role when we start thinking about how to optimize our code
Right.
to minimize the impact of garbage collection.
Yeah. This is already giving me a whole new appreciation for what's happening behind the scenes.
Yeah.
But I have a feeling there might be a downside to all this magic.
You're right. There's always a trade-off. And in this case, it's those dreaded pause times.
Pause times.
Yeah. So while the garbage collector is meticulously cleaning up, all the threads in your application are basically frozen.
Where everything just grinds to a halt.
It does. It has to. It's a necessary evil to prevent chaos.
Okay.
Imagine trying to clean a room while someone keeps tossing clothes and pizza boxes everywhere.
Yeah, right.
The garbage collector needs a moment of peace to ensure it's not deleting objects that are still in use.
Okay, so how noticeable are these pauses? Are we talking like hitting a giant pause button on my application?
For most applications, these pauses are so quick you don't even notice them.
Okay.
But imagine you're dealing with a massive amount of data, especially those large objects in the LOH.
Right.
Suddenly, those pauses become more noticeable, like buffering delays when you're streaming a movie.
Oh, so those are frustrating. Okay, so these pauses are like the GC's Achilles heel.
You could say that.
Okay, well, now I'm really curious about this large object heap, the LOH.
Yeah.
Sounds like it could be a bit of a troublemaker.
It's not really a troublemaker, but it does require special handling. Think of it as the memory heap's VIP section.
Okay.
It's reserved for those massive objects, anything over 85,000 bytes.
Okay, why do these big objects need their own exclusive club?
It comes down to how the garbage collector cleans things up.
Okay.
It uses a process called compacting,
Wait.
rearranging memory, to eliminate those empty spaces, like tidying up a messy closet.
Right.
This is very efficient for smaller objects.
Okay.
But when you're dealing with the behemoths and the LOH, compacting those giants takes more time than it saves.
So they just kind of hang out in the LOH living the good life.
Pretty much, and that can lead to fragmentation.
Fragmentation.
Yeah, which is like trying to fit large pieces of furniture into a room already cluttered with smaller items.
Oh.
You might have enough space overall, but it's not organized in a way that you can use it effectively.
Okay, that makes a lot of sense.
Yeah.
So if we want to write high-performance code,
Yeah.
it sounds like we need to be mindful of this LOH
Definitely.
and how our objects are being managed.
Exactly. And that's what we'll dive into next.
Yep.
While we can't avoid garbage collection entirely,
Right.
there are some clever techniques we can use to minimize its impact and keep those pause times in check.
Okay, let's get into it. I'm ready to level up my coding skills.
All right, let's do it. So are you ready to tame that GC beast?
Yeah, let's unlock those secrets of
Ariel.
high-performance code.
Remember, most code doesn't need these optimizations.
Right.
But for those performance-critical scenarios,
Yeah.
understanding these techniques can really make a difference.
Absolutely. I'm all about squeezing out every little bit of performance
Right.
when it really matters.
Let's dive into those advanced techniques then.
Let's do it.
Let's start with an example that demonstrates how seemingly small choices in data structures can have a huge impact
Okay.
on garbage collection and performance.
Okay.
Remember our discussion about strings
Yeah.
and the large object heap?
Yeah, those large strings can really clog things up if we're not careful.
Exactly. So let's say you need to build a really large string, maybe a log message or a complex data structure. You might be tempted to use a list string.
Right.
And then concatenate everything together at the end.
Yeah, that seems like a reasonable approach.
It does, but a list in .NET is backed by a single array.
Right.
So as your list grows and grows,
Yeah.
that array becomes this massive object, this memory behemoth.
Right.
And where do those behemoths end up?
The LOH.
Yeah, LOH, exactly.
That's worse.
And remember, the LOH isn't compacted as efficiently,
Right.
so you're putting extra pressure on the garbage collector.
Yeah.
Now, the source material we've looked at includes some fascinating benchmarks
Oh, I love a good benchmark.
that really highlight this issue.
Okay, what did they find?
They compared building a large string using a list string
Okay.
versus using the trusty string builder,
Okay, yeah.
and the results are quite striking.
Okay.
For a string with 1 million characters,
A million.
the list approach
Yeah.
ended up consuming over 6 megabit of memory in the LOH.
6 megabytes. That's a lot of memory for just a string.
It is now, the string builder, on the other hand, use a tiny fraction of that memory
Oh, wow.
in the LOH.
Okay.
Why? Because it uses this clever chunking mechanism,
Okay.
breaking the large string down into smaller, more manageable chunks.
It's like packing a suitcase strategically instead of just shoving everything in.
Perfect analogy.
Yeah.
This chunking prevents a single massive object from hogging space in the LOH,
Right.
resulting in significantly less pressure on the garbage collector and much better performance.
So choosing the right data structure can make a big difference.
It really can.
Okay, but what about those situations where we're creating and destroying lots of objects? Are there techniques for handling that?
That's a great question. That's where object pooling comes in.
Object pooling.
Okay, it's a powerful technique for optimizing code that deals with
Okay.
the frequent creation and destruction of expensive objects.
Object pooling. It sounds intriguing.
It is, think of it like a car rental service.
Okay.
Instead of buying a new car every time you need one,
Right.
you simply rent a car from the pool,
Yeah.
use it, and return it when you're done.
Yeah. No need to keep buying and selling cars all the time.
Exactly.
Okay, so how does this apply to code?
Imagine you have a type of object
Yeah.
that requires a lot of resources to create. Maybe it involves complex calculations or network connections.
Right.
Instead of creating and destroying these objects repeatedly, you can create a pool of them up front.
Okay.
When you need one, you borrow it from the pool, use it, and then return it to the pool when you're finished.
So it's like recycling those expensive objects.
It is.
Okay. What are the benefits of using object pooling?
Object pooling can significantly reduce the burden on the garbage collector. Fewer objects are created and destroyed, which means fewer GC cycles.
Right.
And shorter pause times. This can lead to smoother performance,
Okay.
especially in scenarios with tight loops
right.
or frequent object creation.
Sounds like a great technique.
It is.
But are there any downsides to consider?
There are a few trade-offs.
Go.
First, object pooling adds complexity to your code. You need to manage the pool itself, make sure objects are returned correctly,
Right.
and handle potential concurrency issues.
So it's not just a magic bullet for every situation.
Exactly. It's a powerful tool, but it's important to use it strategically.
Right.
You also need to consider the state of the objects in the pool.
Okay.
If you're dealing with objects that have internal state, you need to make sure that state is reset before the object is returned to the pool.
Okay.
Otherwise, you could end up with some unexpected behavior.
And that makes sense.
Yeah.
So far, we've covered data structures and object pooling. Are there any other general guidelines for minimizing the impact of the garbage collector, even if we're not using these advanced techniques?
Absolutely. There are some simple but effective practices that can make a big difference. Remember how the garbage collector works in generations?
Yeah, Gen 1, Gen 2, like sorting laundry?
Exactly. One key principle is to try to keep object lifespans short.
Okay.
Whenever possible, if you can keep those temporary objects in Gen 0,
Right.
the garbage collector can clean them up quickly and efficiently.
It's like keeping our coding workspace tidy, so the cleanup crew has an easier job.
Precisely. Another tip is to use value types strategically.
Okay.
Value types like structs are stored directly in memory, which can often lead to fewer allocations and less pressure on the GC.
So choosing the right data type can also impact garbage collection.
Absolutely. And finally, a simple but often overlooked principle is to avoid unnecessary object creation, reuse objects whenever possible. And be mindful of operations that create a lot of temporary objects, especially within loops.
It's like the coding equivalent of reduce, reuse, recycle.
Exactly. These simple practices can go a long way in keeping your code GC-friendly and performant.
Okay.
Now, while these general tips are a great starting point,
Yeah.
there are even more specialized techniques.
Okay.
For those who really want to delve into the depths of high-performance coding.
Okay.
We've touched on String Builder,
Right.
but there's another powerful player in the .NET world
Okay.
that's worth exploring, Spant.
Ah, Spant. I've heard whispers of this mysterious force in the coding universe.
It is a bit mysterious.
Okay.
Spant is a relatively new addition to .NET,
Okay.
and it's been a game changer for performance optimization.
Okay.
It's a bit more advanced,
Right.
but understanding how it works
Yeah.
can unlock some incredible performance gains.
Okay. I'm intrigued. Let's unravel the mysteries of Spant.
Let's do it.
Okay, let's talk Spant.
Yeah.
Sounds like we're about to unlock some serious performance secrets here.
It's all about efficiency working directly with memory in a way that traditional data structures just can't match.
Okay.
Think of it like a VIP backstage pass
Okay.
that lets you bypass all the usual checks and security lines.
Okay. That sounds pretty cool.
Yeah.
But how does it actually work? What makes Spant so special?
At its core, a span represents a contiguous region of memory,
Yeah.
like a slice of an existing array
Okay.
or a portion of a string.
Okay.
But here's the key. It's just a view,
Okay.
a lightweight pointer into that memory.
Oh.
There's no copying data around or allocating new memory.
So it's like having a window into the memory, allowing us to work directly with the data without all the usual overhead.
Exactly. And because it's so lightweight, it's incredibly efficient.
Right.
No need to go through the garbage collector or deal with the complexities of memory management.
Okay. I'm starting to see why people get excited about Spant.
Yeah.
So how does this all connect back to writing high-performance code?
Remember our discussion about String Builder and how it uses a chunking mechanism?
Yeah, it's like packing a suitcase efficiently, right?
Right. Well, Spant takes that efficiency to a whole new level.
Okay.
There's a special type called Value String Builder,
Okay.
which is essentially a string builder
Right.
built on top of Span.
So it's like a supercharged string builder.
Exactly. Value String Builder uses a span internally to store its characters.
Okay.
benefiting from all those performance advantages we just discussed.
So the benchmarks are pretty impressive.
The benchmarks are very impressive.
Okay, I'm hooked. What kind of performance gains are we talking about?
Well, in their tests, Value String Builder was almost twice as fast as the traditional string builder when dealing with certain string manipulation scenarios.
Twice as fast? Yeah. That's a significant improvement.
It is.
Especially when you consider how often we work with strings.
Yeah.
In our code.
Absolutely.
Wow, this whole deep dive has been incredible.
It has.
We've gone from demystifying the garbage collector to object pooling and now span. I feel like I've learned so much about how to write high-performance code.
Me too.
In .NET.
Yeah, it's been a pleasure sharing these insights.
It really has.
Remember, most code doesn't need these optimizations.
Right.
But when performance is critical, understanding these techniques can give you a real edge.
Absolutely. It's like having a secret weapon.
It is.
In our coding arsenal.
That's a great way to put it.
Any final words of wisdom for our listeners as they kind of go on their coding adventures?
Don't be afraid to experiment. The world of .NET is constantly evolving.
Yeah.
There are always new techniques and tools emerging.
Right.
Challenge assumptions.
Yeah.
Profile your code.
Right.
See what works best for your specific needs.
Right.
Sometimes the most surprising optimizations come from thinking outside the box.
Yeah, that's great advice. And remember, even small improvements can make a big difference in the long run.
They really can.
Well, on that note, we're going to wrap up this deep dive.
Okay.
Huge thank you to our expert for sharing their incredible knowledge and insight.
It was my pleasure.
And to our listeners, thank you for joining us.
Thanks, everyone.
On this exploration of garbage collection and high-performance coding in .NET.
It's been fun.
Until next time, happy coding.